Good morning, students. Welcome once again to our e-learning program. I still remain your mathematics teacher, Mr. Ndubisi Ephraim. Our topic this morning is on three-dimensional shapes. In abbreviation, we call them 3D shapes. And here are the objectives of the lesson. These are some of the things you are expected to comprehend by the end of this learning session. At the end of the lesson, you that is watching the video, the students, should be able to 1. Define three-dimensional shapes. 2. Identify the properties of some three-dimensional shapes. 3. You should be able to solve problems involving the volumes of cube and cuboid. I believe when you are able to comprehend these 3 stated objectives, then you are good to go. So I wish you good luck as we go further in our lesson. Three-dimensional shapes. Geometry is divided into 2 parts. One is called the plane geometry, while the other one is called the solid geometry. The plane geometry was exactly what we discussed during our week 2 discussion, where we talked about the 2-dimensional shapes, otherwise known as the plane shapes. So that is the part of plane geometry. But today we'll be talking about the next other part of it, which is called the solid geometry. In other words, we call them the 3-dimensional shapes. What are these 3-dimensional shapes, or what is a 3-dimensional shape? A 3-dimensional shape, also called solid shape. So another name for it is what? Solid shape. Is a shape which has 3 measurements. The underlying thing here is that they have 3 dimensions or 3 measurements. What are these 3 measurements? The 3 measurements of length, breadth, and the height. Once you can establish that a shape has these qualities of having the length, the breadth, and the height, then you qualify such shape as a 3-dimensional shapes. Unlike the plane shapes, where we talked about the flat surface, we were not dealing with the inside of the shape, rather on the flat surface of the shape. This particular one will be dealing with a shape that has an inside and also an outside. And such shapes are called 3-dimensional shapes. In other words, we call them the solid shapes. Alright, let's move further. We have some examples of 3-dimensional shapes, and they include the cube, cuboids, cone, cylinder, prism, tetrahedron, sphere, pyramid, etc. These are some of the examples of 3-dimensional shapes. Now let's look at their diagrams or their pictures for you to be able to identify them properly whenever you see them. Here are some of their examples in pictures. This is the one called cylinder. It looks quite like your tea milk. Alright, we call it the cylinder, and it's a 3-dimensional shape. Then another one, we have cuboid, which look like the matchbox, the one you call matches, the matchbox. Okay, so that is a perfect example of 3D shape as well. Then we have the cube. We have a magic cube. You must have seen magic cube, in which the 6 faces are identical. That is to say, they are equal. Even their edges are equal in size. So such a shape is called a cube. The reason why we can say that all the surfaces are equal is because all of them are square in nature. You know what a square shape is? That all the sides of a square shape, they are what? Equal. Alright, so we move to the next one. That is a pyramid. This one is called a rectangular pyramid because it has its base as a rectangle, as you can see from the diagram. It has its base as a rectangle. So this is a rectangular pyramid. Here we have a cone. This one looks quite like a cowboy's cap, like a title man's cap. You must have seen this quite a lot. So such a shape is called a cone. Then we have another one called triangular prism. Triangular prism is another example of this. You can see the shape is made up of different triangles. Okay, made up of different triangles on the various part of this shape. Here we have another one called the tetrahedron. This is the perfect shape of tetrahedron. Then another one is the sphere. This one looks like the shape of the earth, or the shape of an egg. When you handle your egg, you find out that it is not a perfect circle. Okay, a perfect circle is not a sphere. A sphere is quite different from that. So we usually say that the earth is spherical in nature, and this is the perfect description of it, and we call it what? The sphere. Good. I believe we've been able to achieve something here. Okay, now let's move to the next one. Now we'll be talking about the properties of the 3D shapes, three-dimensional shapes, and we'll be starting with the properties of cube and cuboid. You can see their pictures here. Let's describe some of their properties. You can see the sharp edge here, the sharp edge of it here. You can see the sharp edge. The sharp edge. We have 8 sharp edges here. You can see it from here. You also have another one here. You have another one here. Yet another one. You have it here. Then another one. You have it here. So how many in number? You have these 8 sharp points there, which we call the vertex. We call these sharp points, these ends, we call them the vertex, where the 2 lines meet. Alright, so the 3 lines, as the case may be, this one coming from here, then this other one coming from here, this other one coming from here, giving us this sharp edge of the shape, and we call it what? The vertex point. Alright, so let's identify the properties of a cube. 1, it has 6 square faces. It's not just 6 faces, but 6 square faces. And being that it has 6 square faces means that all the faces are identical. They are equal in nature. Recall that a square has all its sides equal in size. Alright, so we say that it has 6 square faces. You can use your magic cube to identify that. Count the number of faces it has. You find out that they are 6 in number. 2, it has 8 vertices. That is the vertex points that we identified now. That's 1, 2, 3, 4, 5, 6, 7, 8. So how many vertices? 8 vertices. Good. Now the next one, it has 12 edges. Here are the edges. You can see the edge here. These are the edges. So here we can count them to be, this is number 1. That's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it has 12 edges. In summary, you can say a square, that's a cube, has 6 square faces, 8 vertices, and 12 edges. This one seems to share that similar characteristic, that is the cuboid, seems to share this similar characteristic with the cube. But this time around, one difference between them is that this one has 6 square faces, while this one has 6 rectangular faces, because their faces looks like a rectangle. So for that of a cuboid, it has 6 rectangular faces, while that of a cube has 6 square faces. as the case may be. Now let's move to the next one. Number 2, it has 8 vertices, just like the one of cube. And lastly, it has 12 edges, just like a cube as well. Alright, so those are the properties of cube and cuboid. I believe if I ask you to identify the similarities between a cube and a cuboid, you should be able to identify that, being that each of them has 8 vertices, and each of them also has what? 12 edges. Alright, so those are the properties of cube and cuboid. Now let's quickly move to the next ones. Here we have the properties of pyramid. Properties of pyramid. That's we call it the rectangular pyramid because it contains a rectangle as a base. Now here are the properties of this pyramid. 1, it has 5 faces. When you count the number of faces, this one 1, this one 2, the other one at the back of this 3, here this one 4, and the one under, which is the rectangular part, is what makes it what? The 5th. Alright, so we can say that it has 5 faces, and these 5 faces are made up of 4 triangles. You can see 1, 2, then another one here 3, then the other one at the behind here is 4. So it has 4 triangles and 1 rectangle. The rectangle is the base part of it. You can see it here. That is the rectangular part of it. That's the rectangular part of it. Alright, so those are the properties of pyramid. Now let's look at the properties of cone. Look at the cone, the one I said that it looks like the title man's cap. Alright, so here are the properties. It has 1 curved surface. You can see round surface. This is what we call the surface. It looks round. So we have 1 curved surface. Okay. Then again, it has 1 circular surface. You can see 1 circular surface here. Then it has 1 edge. Only 1 edge. We describe the edge as the round nature of it. That is 1 edge that it has. Alright. Then the last one, it has 1 vertex. That means it has 1 sharp point, as you can see from here. So those are the properties of cone, as you can see from the diagram. Now let's quickly move to the next one. The properties of a cylinder. This is the one that look quite like your tin milk. Alright, properties of a cylinder. Okay, as you can see, it has 1 curved surface, just like the one we described earlier on. That's the cone. It has 1 curved surface. That's the round nature of it. That's 1 curved surface. 2, it has 2 flat circular surfaces here, or faces rather. You can see the circular face here, another circular face here. So it has 2 circular faces. 3, it has 2 circular edges. So we have 1 edge here of a circle, then we have another edge of a circle here. So it has 2 circular edges. Then number 4, it has no vertex. When you look at it here, it doesn't have a sharp point, just like the previous ones that we just identified. It has no sharp edge here. It doesn't have a sharp edge. Unlike this one has 5 vertices. You can see 5. This is a vertex. This is a vertex. This is a vertex. This vertex point. This is a vertex point. So this one has just one sharp point there. But in the case of cylinder, it has no sharp point. So you can say it has no vertex. That's what we can use to qualify it again. All right, let's quickly move to the next one, which is a prism. Properties of triangular prism. 1, it has 6 vertices. You can see 1, 2, 3, 4, 5, and 6. So 6 vertices. Then the next one, it has 9 edges. You can see the edges. 1, 2, 3, 4, 5, 6, then 7, 8, then the other part of it 9, going like this. So it has 9 edges. Then finally, it has 5 faces, and these 5 faces is made up of 2 triangles. As you can see, this is a triangle there, This is another triangle there. And 3 rectangles. You can see this is the perfect shape of a rectangle, as you can see from here. Rectangle 1, another one is behind, then another one under. So it has 3 rectangles. So overall it has 5 faces, and these 5 faces made up of 2 triangles and 3 rectangles. Good. Let's move to the next slide. Now we are to discuss the volumes of 3D shapes. According to our scheme, we're asked to discuss on the volumes of cube and cuboid. But notwithstanding, I will be giving you formulas of some other ones so that you get familiar with them ahead of time. Alright, so the volumes of cube and cuboid. Let's start with that of a cube. A cube, just like we said, they have 6 square faces, meaning that each of the edges are equal. Each of their edges are equal. So if this place is being identified as length, this other side should also be what? The length. Okay? Because all the sides are equal. Alright, so this is the length, this is the length, this is the length. The 3 dimensions of it. So therefore, the volume of a cube is equal to length cube. That's the length raised to power 3, which means length times length times length. That's into 3 parts. You multiply them into 3 parts. Alright, so that is the formula for calculating the volume of a cube. In some textbooks, you may see it as S cube, S raised to power 3. That S also represents side, okay, which is still the same thing as what we have here. In other textbooks, you may see it as X cube. So it depends on what they decide to name the side. So, but it doesn't matter much, in as much as you specify that that particular alphabet represents the side or the edge of the cube. Alright, let's quickly move to the next one. That is a cuboid. Then the formula for calculating the volume of a cuboid, you can see it has its length. It has its length here. It has the width, which we can also call the breadth. Then we have the height here. Alright, so the 3 dimensions. The volume of cuboid is given as length times width times height. Length times width times height. That is the formula for calculating the volume of cuboid. Now let's move to see some worked examples of this calculation aspect of it. Here we have calculations to perform the volume of cube and cuboid. Here you have a question. A cube of side 5 centimeter. Recall that if this place is 5 centimeter, what do you think this place will be? 5 centimeters as well. And this place as well will be 5 centimeter, because this shape of a cube has 6 square faces, and the square, all sides are equal. So that exemplifies exactly what we are showcasing here. So that is to say, if one side of the cube is given, it means that that side given is the same as other 2 remaining sides, which completes the 3 dimensions of this particular shape. So here we are being given the length as 5, the length as 5, and we know that the formula for calculating the volume of cube is length cube, which means length times length times length. So here we substitute our length, okay, being 5, the length is 5. So we now substitute our length to be 5, just like it is given in the question. So we now say 5 raised to power 3, which means 5 times 5 times 5. 5 times 5, 25. And 25 times 5 will give us what? 125 centimeter cube. Remember, the unit is centimeter cube. The unit of volume is either centimeter cube or meter cube. Don't make mistake about that. Centimeter cube or meter cube. That is the unit of volume. All right, so whenever you finish calculating anything, any shape, giving calculation of any shape, as in terms of volume, its volume, you should be able to put the unit of that particular volume given, volume of the particular shape given. If it's given in centimeter, you identify it as what? Centimeter cube. If it's given in meter, you identify it as what? Meter cube, as the case may be. All right, so let's quickly move down to this very one. Here you have cuboid of different dimensions. Here you have 3 meters. Here you have 6 meters as length, and here you have the height as well, 5 meters. How do we find the volume of this particular shape? When you look at the question here, you find out that you have different dimensions of it. You have the width, you have the length, and you have the height. And the volume of cuboid says length times width times height. All you do is to multiply all the 3 dimensions. Okay, it doesn't matter whether you start with width, whether you start with height, or whether you start with the length. The most important thing is that you multiply the 3 dimensions. And here we have it. The volume is equal to 6 as length times 3 as width and times 5 as the height. So 6 times 3 will give us 18, and 18 times 5 will give us 90 meter. That should be meter cube, not centimeter cube. So meter cube is what we're supposed to have there. Meter cube. Sorry about that. Meter cube. So we're supposed to have it as meter cube, not centimeter cube. All right, so that's the solution to the 2 questions. So whenever a question is being given to you in terms of cube, so the length is given, you multiply the length given into 3 parts. Okay, that's you multiply it into 3 of itself. So the next one is a cuboid. Whenever you are being given a certain shape of cuboid, to find its volume, all you need to do is to multiply the 3 dimensions given, the 3 dimensions of the length, the width, and the height, which is exactly what we did here. So those are the solutions of the volumes of cube and cuboid. All right, then let's quickly move to the next one. Word problems. Let's quickly discuss these word problems. Find the length of a box whose volume is 60 meter cube with the width and height measuring 4 meters and 5 meters respectively. They said find the length of a box whose volume is 60 meter cube with the width and height measuring 4 meters and 5 meters respectively. That is to say, we are being given the width as 4, we are being given the height as 5. Whenever a statement reads respectively, it means you have to place them in the order of the way they appear. So like width is mentioned first, that means it has the first number mentioned here, and the height is mentioned second, that means it has the second number given here respectively. All right, so let's quickly solve this. This time around, we are not looking for the volume because the volume is given to us in the question. Whenever you see something given as meter cube or centimeter cube, that means you are talking about volume of a certain shape. So the volume is given to us as 60 meter cube, and the width is given to us as 4 meters, and the height is given to us as what? 5 meters. Now let's quickly give solution to this. We are looking for the length. Remember, they say find the length. Know the one you are looking for. We are looking for the length. So let's bring out the information. The volume is given to us as 60 meter cube. The width is given to us as 4 meters, and the height is given to us as 5 meters. And we are looking for what? The length. That's why we put a question mark there. We are looking for it. All right, for us to solve this, when you look at the question here, you find out that we are dealing with the width, height, and length. And which aspect are we talking about? Is it the cube or cuboid? It's actually the cuboid, because the cuboid has these 3 dimensions of length, width, and height, as is mentioned in the question. You can see the three of them are mentioned in the question. That will give you an idea to which particular one you have to make use of. Alright, having said that, let's quickly begin to solve the question. So the volume is given to us as 60 meter cube, okay, and the width is given to us as 4 meters, okay, then the height is given to us as 5 meters. Alright, so we're looking for the length. The formula says volume equal to length times width times height, okay, and we're looking for the length. Let's substitute the values. We have 60 equal to length is given is not given to us, that's what we're looking for, so we write it the way it is, times the width is given to us as 4, so we replace it with 4. The height is given to us as 5, so we replace the height with what? 5. So we can now simplify further. Bring down our 60 is equal to length times 4 will give us 4 length. 4 length times 5 will give us 20 length. Or you can put it this way, 4 times 5, 20. Then 20 times length will give us 20 length. So we divide both sides by the coefficient of length. And what is the coefficient of length here? 20. So we divide both sides by 20. When you divide both sides by 20, what do you have? We'll actually be having something very interesting here as our answer. Divide both sides by 20. Divide both sides by 20. You do something here. What you do to the left hand side, do the same thing to the right hand side. So we divide both sides by the coefficients of length, which is what? 20. Alright, having done that, so 20 can cancel 20 as we have it here. 20 can cancel 20. Then we are left with what? Length as we have it here is equal to, then this 0 will cancel this 0. Okay, when it cancels, then we are now left with what? 6 over 2. So 6 divided by 2 will give us what? 3. That's 3 meters as we have it here. Or you can quickly do it this way, that length is equal to 60 divided by 20. Then 0 will cancel out what? 0 from here. Then 6 divided by 2 will give you what? 3. So that is the answer to the question, 3 meters. Alright, let's quickly move to the next solution. Here we have another question, which is the final one we have for today. Say, find the length of a cube whose volume is 27 meter cube. We are looking for the length of a cube whose volume is 27 meter cube. Unlike the previous question we just solved, where we are having other dimensions mentioned here as width and height, as well as we are being asked to find the length. So it means that we are solving for the cuboid, the volume of cuboid. But this time around, we are being given only the volume and we're asked to find the length, and no other side is given. That is a perfect way to know that you are solving for the volume of cube, as you can see from the question. So remember that in cube, all the dimensions are equal because their faces are square in nature. Alright, so we are looking for the length whereby the volume is given to us as 27 meter cube. Now here the volume is given to us as 27 meter cube. The length is what we are looking for. Then the volume, the formula for finding the volume of cube is length cube, or length raised to power 3, which is something as length times length times length. Okay, having done that, let's substitute the values. The volume is given to us as 27, so in place of this volume we write 27 equal to, bring down our equal to, then length cube, because we are looking for the length. So what do? It's just like asking, what number do you multiply to itself 3 times to give us 27? Which number is that? Which number do you multiply to itself 3 times to give us 27? And that number is 3. Because when you say 3 times 3 times 3, that will give you what? 27. So therefore, we can solve this mathematically by placing it like this. It's just like saying apply cube root on both sides. And when you do that, this one will cancel out. Then this one will now become the cube root of what? 27, which is something as what I did here. Okay, so you can do it like this, or you do it this way and get your answer. So the cube root of 27 is what? 3, because 3 times 3 times 3 into 3 places will give us what? 27 as our answer. So that is how to go about this. Let me take it again so that you get to understand it better. So the volume is given to us as 27 meter cube. The length is what we are looking for. And the formula for finding the volume of cube is length cube, which means length times length times length. So what the number you times to itself 3 times here to give you the number given as volume is actually the answer to that question. So here we have the volume given to us as 27 equal to length cube. That is exactly what we are looking for. So which number do we multiply to itself 3 times to give us 27? And that number is what? 3. Therefore, the cube root of 27 is equal to what? 3 meters as our answer. I hope it's quite clear. So here we'll be coming to the end of the lesson for today. But before we conclude, let's quickly go through the formulas for calculating the volumes of other 3-dimensional shapes, which include the volume of cylinder. The volume of cylinder is given as pi r squared h. If you recall from what we solved initially, you find out that this cylinder, it has a height, as you can see. This is the height of the cylinder, and it has radius because it has a circular part. Because that the formula for finding the area of a circle is pi r squared. So it has circle as its base. Okay, so that's why we said pi r squared h as the volume of the cylinder. Now let's quickly run to other ones. Then volume of cone. Volume of cone is given as 1/3 of pi r squared h, or 1/3 times pi r squared h. That is the formula for calculating the volume of a cone. Then for that of a sphere, the formula is 4/3 times pi r cube. So those are the formulas for calculating these other volumes of 3-dimensional shapes. I hope we've been able to achieve something today. So I say goodbye to you here, and here are the assignments you are to take. The first one, you have to find the volume of the cube we have here as the length 8 centimeter. You have to find the volume of the cuboid we have here of different dimensions of 3 meters, 11 meters, and 4 meters respectively. Then you have to find the length of a cube whose volume is 64 meter cube. Then a cuboid has dash faces, dash vertices, and dash edges. So you give answer to that. A pyramid has dash number of vertices. Has it any vertices? Or tell me the number of vertices that it has. Then finally, give 2 examples of objects with the shape of a cylinder. In your environment, look around your environment and try to find out the shape that has you can use to describe cylinder within your environment. So here we draw the curtain for today, and I say a very wonderful goodbye to you. Have a nice day, and I look forward to seeing you in our next lesson as we go further. Thank you, and God bless you. Bye.